Good morning. All right, as she said, my name's Deborah Kurata. I'm a Google GDE. I'm very, very lucky in that I live in the San Francisco Bay / Silicon Valley area. So our local Angular user group is actually at the Google offices of the Angular team. So that's really fun. We get to hear all the inside scoop on everything, so it's really fun. All right. So today we're going to merge some streams. So I don't know how many of you are old enough to recognize this, but all right. So what we're really going to do today is we're going to take a declarative approach to collecting, combining, and caching our streams using RxJS with no subscriptions. The best thing about not having to subscribe is not having to unsubscribe. All right, so this is the sample application that we'll sort of be looking at. It's your typical kind of app where you've got a bunch of list of stuff on the left and the user picks one of those and then it displays the details on the right. So that's kind of the simple bit we're going to be looking at for our time together here. So, but before we can put anything on the screen, we've got to collect that data, right? We've got to go get that data from an endpoint somewhere, from a backend server or wherever that we're getting our data from. Now, if you're like me, we learned how to do our data collecting, our data retrieval like this, right? We build a get method in a service, and it calls HTTP get and returns your observable. Then in your component, you have an ng-on-init method that calls this method and returns your observable, which you then put into an array and bind to your array. Okay, so this is all procedural, lots of methods that we're creating. What if we started thinking about this another way, using a more declarative approach? And we do something more like this. So instead of creating a method that's returning our observable, we're actually creating a property. So here we've got products $, and we're setting that equal to the result of our HTTP get. Now the dollar ending on this is kind of a convention that people have started to use to identify this as a property that returns an observable, as opposed to a property that returns a more simple type like an array or an object. Okay, so what does that mean for our component then? So our component would look something like this. So it would also have a local property, products $, and we're going to assign it to the services products $, property. So now we have a property that represents an observable, instead of having something that's converting that into an array or an object. So what do we do in the template then to bind to that thing? Well, we can use the async pipe. So using the async pipe, we can use our products $, property from our component. One of the best things about the async pipe is when this page is created, it automatically subscribes for us. When this page is destroyed, it automatically unsubscribes for us. Yay! So we don't have to do that. All right, and notice I'm using the as syntax here. And what that does is every time the products $, observable emits a value, it assigns that value into that variable. So when the data is returned from the HTTP get, the products $, in our service emits the array of products. Our component then emits that array of products to our template, and our template assigns it, our template assigns it to that products $, variable that we can then use anywhere else in our template. Okay, so now that we can do this, we can start using on-push change detection. Now, when I first learned change detection, well, first of all, on-push improves performance by minimizing the change detection cycles. So you can get better performance, especially if you have a lot of elements on your UI, or if your UI is showing a lot of data. Now, if you're like me, we learned that you can only use on-push if you're working with child components, and they have input properties, and they're sending out events, event emitter style events. But the thing that's important for us for this discussion is you can also use onPush if your binding is to an observable that's going to be emitting values, because then every single time a new value is emitted, change detection, the onPush change detection will pick that up and update your UI. So you can get the performance benefits of onPush, but use a declarative approach for your code. So the question now is why, right? Why would we want to do it this way as opposed to the way that we all learned when we were first starting? The first is, of course, what I just showed you. Improved change detection gives you improved performance. In addition, you can leverage RxJS operators. So you can use its filter operator or its accumulation operators to better manage your data. Thirdly, we can compose our streams. So we can combine data by composing our streams together. And we're going to see examples of that here shortly. And lastly, you can more easily react to user changes. And we're going to talk about that in this session also, how we react to user changes. All right, so now we've collected our data, and now we have it in kind of live streams where we have our template actually binding directly to our observable. So the next thing that we want to talk about is how you combine or compose these streams. So it turns out that when we first get our product data from the server, that our category that we want to display on our UI is a number. So we've got a category ID of 3. Now our users don't know what a category ID of 3 is. What we really want is we want to show the category name, like toolbox or garden or whatever our type of product is. So how do we do that? Well, it turns out that we have another endpoint where we can get our lookup data. So we've got another endpoint that's going to give us our category IDs and our category names, so we can pull that down as well. And we would use code very similar to what we just looked at for our products dollar. In a service, like a product category service, we then have a product categories dollar stream that we're assigning to the result of the HTTP GET operation. Okay, so now we have 2 streams. We've got our products dollar stream that has the category ID in it, and we've got our product category stream that has the ID with the lookup string value. How do we combine them? Well, one option is to use combineLatest. So combineLatest is an actual RxJS creation function that we can use to combine our streams. So we're going to combine our products dollar stream, and our product categories dollar stream together so that we can work with both of them in our pipeline. Okay, so what combineLatest does is it combines these 2 streams. And what, let's see, there it is. It uses the latest value, hence the name combineLatest. It uses the latest value for each stream. And combineLatest itself won't emit until all of the combined streams emit at least once. And as we all know, when we do an HTTP GET, it emits once. It's one and done. So this is going to wait for the products dollar stream to emit and complete, and it's going to wait for the product category stream to emit and complete. And then it emits. What does the combineLatest emit? It emits an array where the first element of the array is the emitted value from the first stream, and the second element of the array is the emitted value from the second stream. And if we had a third stream, that would be the third element, and so on. So you can almost kind of think of combineLatest as a way to kind of create a routine that you're passing values into. So here we're passing in quotes, passing in, air quotes, this products dollar stream, our emitted value from that, and our emitted value from the products category. Then what can we do with this? Well, we can pipe it through a set of operators, right? Anytime we're emitting values from an observable, we can pipe those through operators. So the first operator we're going to pipe it through is a map, because what our goal is is to map our product with a category ID into a different kind of product that then has the product category name. So the first thing I'm doing is using array destructuring. And array destructuring is a feature of JavaScript, and all that it's doing is it's letting us assign a variable name to that array element. So instead of having to say bracket 0 bracket to get at that first element and bracket 1 bracket to get at the second element, we can just assign variables to them. So our products dollar is the value emitted from our products dollar stream, and our categories is the value emitted from our product category stream. Are we good so far? Yeah? Great. Okay. So then what do we do? So now that we have our products and our categories, we can use the products array map, and we can convert or map our product. So what we're going to do is we're going to start with our product that we're getting from the products, we're going to start with the product from our product array that we got from the products dollar observable, and we are going to create a new product. So the first thing we're going to use is the spread operator to create a copy of it. So we're going to create a copy of our original product, and then we're going to add the category property onto it. So now our new product that we've just created is the same as the old product with an additional property for this category name. And we use the categories array that got passed in, and again I use air quote on passed because it's not really passed in, it's emitted from these streams. And we're going to find on that in order to find the category name that is the same as our lookup value ID. Lastly, we want to define the resulting type, because the observable coming out of this stream, our products with category dollar, we want to be emitting an array of product. Okay, so we ensure that each individual product that we're creating from the products in the array are indeed still of type product. So what does that mean in terms of our component? We can simply change our products dollar in our component to assign it to our products with category, because it's still returning that, or it's still emitting an array of product. Making sense? Excellent. You guys are awake this morning. All right. So, voila. If we modify our binding to bind to this new category's property instead of the category ID, our UI then can show them the name of the category instead of the less helpful category ID. Seems good, right? Helpful for our users. All right, so what about this part down here? Okay, every one of our products also comes with that product data as a set of IDs of all of its suppliers. So who are we getting this product from that we're reselling? How do we deal with that? Well, what we need to do is combine higher order observables. So the first question is, what the heck is a higher order observable, right? At least that was my first question when I read the docs and it started talking about inner observables and outer observables and higher order observables, and I'm like, what the heck are you talking about? So what is a higher order observable? Well, when we think of observables, we might be thinking of something like this. So here I've got the of creation function, and I'm using a marble diagram here. And so this is emitting a 2, then it's emitting a 3, then it's emitting a 4, and the slash through the 4 means it's a complete, because the of creation function will emit each of the values in complete. So that's a simple observable, or it's sometimes called a first order observable. Now, the ones in Angular that we frequently work with are these kind, the kind that we get from HTTP GET. And what that is doing is it's one and done, as we mentioned earlier, and so I'm getting an array of product objects. So I just have 2 in there, P1 and P2 are my 2 products. That's all I could fit in my marble. But you can imagine that there could be hundreds of those little things in there. Okay, so those are also somewhat simpler of an observable. You get to higher order observables when you start to try to do something like this. Okay, so here I've got an of 3 and 7. You can think of those as 2 IDs for my suppliers, and I'm piping them through, and I'm trying to map each of those IDs into another observable. And so that is a higher order observable. So a higher order observable is an observable that emits other observables. Okay, so here my of 3 and 7 is in the inside generating additional observables. Okay, so if you have any RxJS experience at all, if you look at this code, you might see exactly immediately what's wrong. What's wrong with this code? Anyone see it? I'm subscribing to the outer observable. That subscribe on the end is subscribing to the of 3 and 7. What is subscribing to that inner observable? And actually, this thing is never going to actually emit supplier 3 and a supplier 7 because I am not subscribing to that inner observable. And again, the inner observable is the one inside the pipe there. My outer observable is that of 3 and 7. Now what? Now what do I do? Well, I could do something like this that looks kind of nasty. And you notice I marked it as an anti-pattern. This isn't the one you want to take a picture of and say, hey guys, we should be doing this. Deborah said this is the way to do it. No. So what we're doing here is we have our first observable, which is our HTTP GET on our product. Then we're pulling off the supplier IDs, and then there's our inner observable, and we've got nested subscribes. Okay, so how do we make this code then work with an async pipe? I don't know. How do we unsubscribe from this thing? I don't know. Let's not do this. I should have drawn a big X through this. But we don't want to do it this way because it's problematic. So what do we do instead? We use something called higher order mapping operators. We've got higher order observables. We've got mapping operators to help map those observables. I'm going to talk about 3 of them. So the first one I'm going to talk about is concatMap. Right? So concatMap. Here again, I have an observable of 15 and 42, and I'm using concatMap, and I want to thank Michael, who I think is in the back. Thank you for helping me with the marble diagrams. Anyway, so concatMap waits. So what it does is it will emit the 15, it will issue the HTTP GET request, wait for the response. When it receives the response, then it will process the 42 and issue that request. Okay, so that's how concatMap is different from the other higher order mapping operators. The next one is mergeMap. Now mergeMap runs these things in parallel. So as soon as it gets 15, it launches that HTTP GET. When it emits the 42, it runs that HTTP GET. Okay, so the difference between mergeMap and the other higher order observables is that it runs it all in parallel. The last one I wanted to talk about is SwitchMap. SwitchMap always wants the latest thing. You know, kind of like if you have teenagers, they always want the latest thing, right? So that's kind of like SwitchMap is. It always wants to switch to the latest one. So this emits 15, it executes the HTTP GET request, and before it's even had a chance to reply, the 42 is emitted, so it unsubscribes from that first one and subscribes to the second one. And it goes to get the second supplier. Okay? So in our case, in our example of trying to get suppliers for a product, which one would you guess we would want to use? mergeMap, yes, thank you. So here it is. So I'm pulling my supplier IDs. I'm using mergeMap because I want to get them all, and I don't really care what order that they're in, and I want it to be quick, so I want them all to run in parallel. Okay? All right. Reacting to actions. So when the user clicks on something on the left, we want the UI to automatically update to display whatever they picked on the right. Right? Sounds easy enough, right? So how do we do that in now our declarative reactive world here that we've just created for ourselves? Click, display, there you go. All right, so we've already said that our data stream is one and done. So we have our set of data, and here I was able to fit 3 products in there, saw, rake, and axe. So it's an array of products. How do we react to actions? Well, what we can do is create another stream with the actions in it. So when the user clicks 1, we put the 1 in the stream. When the user clicks, and then if we combine those, we can get all of the data for both streams. So then we can put it through our pipeline and do something with it. Then when the user picks another product with an ID of 14, what it will do is it will re-emit the latest version. Remember we just talked about combineLatest. We'll emit the latest version. So it will again give us our data along with our new action if we combine those streams. So our steps for creating actions are to start by creating an action stream, then combine our action stream with our data stream, and then every time the user performs an action, we emit to the action stream. Okay, so what does that look like? How do we go about doing that? Creating an action stream is often done by using a subject or a behavior subject. A subject and behavior subject are a special kind of observable that are multicast. With a normal observable, when someone subscribes, they get their own copy of the observable results. So if you subscribe and then you subscribe, you each get a copy and we're not sharing the result. With a subject and behavior subject, it shares the result of the observable. The other difference is that a subject and behavior subject can behave as an observable and as an observer, meaning it has next, error, and complete methods. So we can use that next method to get stuff into the stream. All right, let me go back to that just for a second. So what we've created here is our product selected subject, and then from that we've got our product selected action dollar, which is our observable from that subject. Okay. So then we're defining our selected product dollar stream is a combination of our products with category. That again is our product stream with our mapped category name instead of the ID, along with our new product selected action stream. So what we get out of that then is an array where the first element is the products, and the second element of that array is the selected product ID. So we again use array destructuring to give them good names, make the code a little easier to read. Okay, are we still doing well? Yeah, great. All right, so then we just use the products find method to find that particular product. So every single time the user picks a different product, it is going to re-emit something, or we want to re-emit something into that stream. So how do we do that? Well, in our template, we're going to have, tied to that element, we're going to have an onSelected method. So it's going to do event binding into onSelected. Our onSelected method is going to call a method in our service, and our service is going to use the subject, call the next method, to add the ID of the selected one into the stream. Okay, so our data stream was one and done. We get that one time, and then it will just keep giving us that value, that latest value. Our action stream, every time we put one in, it will re-execute our pipeline. So let's look at that from a picture point of view again. So there is our data stream on the top, our action stream at the bottom. Notice the data stream is complete. It has the line through it. Our action stream can continue on indefinitely. And we use combineLatest, and we get then both our data and the action value. Then if the user picks a different one, it re-emits. So again, we have the data and we have the action value. Then it will re-execute that pipeline. So every time the product selected action emits, it will execute the pipeline and find the product that they just picked. Selected product will re-emit. It will then, if there's a property in the component that's associated with selected product, it will emit to the UI. And if we're using an async pipe, our UI will redisplay because we have on-push change detection set, and it will redisplay every time a new value is emitted to the async pipe. All right. caching. Now, if the user starts on the home page and clicks on product list, this page first appears and it will go get all of its data because the async pipe is launching all of the HTTP gets. When the user goes back to the home page, the page is destroyed and all the values that we collected are gone. If the user navigates back to the product list, it goes and gets all your values again. Now, if you're doing something like airline travel reservations like we saw this morning, you might need to do that. But if you've got something like products that only change once a month or product categories that maybe change once a year, there's no reason to be getting this data as the user's navigating around your app. So what you can do is you can use caching. Now, we might have learned to do caching this way, where you stick it into a array in your service, and then everyone can access that array. But this won't work with our new declarative approach, right? So we can instead use share replay. And share replay is an operator that allows us to share this observable with any other subscribers, and it remains active even if there are no current subscribers. So if the user goes to the home page and there are no more subscribers on our product category or our product, it will still retain it. So the next time the user goes to the page, that data is going to display instantly because it's not going to go to the server again. Okay, so that's caching. All right, the last thing I want to talk about then is observable all the things. Okay, so if we have followed these techniques and we've done some of these things like we've talked about, we might end up with a whole bunch of observables that we're binding to in our template. Right, so we've got our supplier observable that we're binding to, we've got our product, selected product observable we're binding to, and maybe we want our page title to also change as the product changes. You know, it seems like we're going to have a lot of observables that we're trying to deal with in our UI. What if we combined all of the observables for a page together? So, in our component, we would have our product dollar stream, which is just associated with that selected product dollar stream we saw a moment ago, the one that's combined with our action stream. How do we do the page title? Well, what we can do is start with the product, and we can use a map operator to map that product into a string. So all we're doing with that observable is piping it through a map and doing a string replacement on it. Kind of cool? Yeah? And then, of course, our suppliers. So that was the suppliers for the bottom part of the stream. And now we are going to merge all of our streams together. So how do we do that? What did we already learn? How to combine our streams? concatMap, or combineLatest, that's right. Not concatMap, combineLatest. You're right. All right, combineLatest. So here we've got our three streams. Our stream that's displaying the product information, our stream that's displaying the product suppliers underneath it, and our page title. So what are we doing here in our pipe? Well, this first thing is that if the user has not yet picked a product, like when the screen first comes up, we don't want it to try to do any mapping because we don't have a product yet. So we skip it. So that's what the little filter's for. Then we are doing our mapping. And what this is doing is it's again using array destructuring. So I've got the product emitted from the product's observable, the product suppliers emitted from the product suppliers observable, and our page title string emitted from the page title dollar observable. And what we're doing is we're just mapping those array elements into an object. Okay, so that syntax looks a little odd, but by mapping it to an object, we can use the dot syntax in our template. Okay, and Xander Elias was the one who first showed me this technique, and it was just blown away how cool this was. Okay, and we use the VM dollar, sort of a throwback to Angular JS, if you ever use that. Anyway, all right, so then in our template, we have an ngIf, and we only have then one async pipe for this combined stream. So we're emitting into the VM variable, then because we mapped it to an object, we can get at everything else using the simple dot syntax. VM dot page title, VM dot product, VM dot product suppliers. So one async pipe, simple binding in our template, 0 subscribes in our code, 0 unsubscribes in our code. So declarative reactive streams have a couple of cons. Picking the right operator is not always easy, and it's sometimes difficult to debug observables, though I understand that there is work being done on this at this point. But there are lots of pros to this that we've already talked about. And with that, my slides are here. My code is there. Feel free to reach out to me on Twitter. Thank you all very much.